Hey guys, welcome to our YouTube channel. In this video, we are going to discuss the solutions of the first three problems of the Leetcode Weekly Contest 394. Let's start with the first problem. So, in the first problem, it says that you're given a string word. A letter is called special if it appears both in lowercase and uppercase in a word. Return the number of special letters in the word. So, the solution for this is very straightforward. You will simply create two arrays. One will store if a particular character has appeared in an uppercase, and the other will store if a particular character has appeared in a lowercase. And at the end, you're simply going to iterate over all the characters and count the number of characters which have appeared both as an uppercase and a lowercase characters. So let's quickly write the code for this. So I'm going to create a Boolean lower array which will store the uh, lowercase characters, Boolean upper, which will store the uppercase character. So the lower array will store lower of 0 will store if lowercase a has appeared, lower of 1 will store if lower of lowercase b has appeared, lower of 2 will store if lowercase c will appear, c has c is present in the string or not, and so on for all the remaining characters. Similarly for uppercase array as well. Then we just have to simply mark each character in the lower and upper array. So for each character in the word, so for I is equals to 0, I less than word dot size I plus plus. Now I have to check if each character in the word is an uppercase character or a lowercase character. I can use the ASCII range for this. For example, uh, lowercase characters have an ASCII range 97 from to 126. Similarly, uppercase have an ASCII range. Now, if I simply check uh, the ranges of these, if the current character is falls between the lowercase range or the uppercase range, it will work. There is also a very easy way to do this. So, all you have to do is check if word of I, which is the current character, and 1 left shift 5 equals to 0. So all the lowercase values, uh, lowercase letters, ASCII values will have the first fifth bit as set. The ASCII value of all the lowercase characters will have the fifth bit as set. Similarly, the ASCII values of all the uppercase characters will have the fifth bit as unset. So if the fifth bit is unset, word and 1 left shift 5 will give me if fifth bit is set or not. If it is unset, I'm going to simply uh, make upper of word of I minus uppercase A is equals to true. So word of I will give me the ASCII value of the current character minus A will give me the corresponding index. So for A's index is 0, B's index is 1, and so on. Else, that means it is a lowercase character. So I will do lower of word of I minus small a this time equals to true. At the end, all I have to do is simply iterate on all the 26 characters. Int I is equals to 0, I less than 26, I plus plus. If a character is present as both an uppercase and a lowercase, then I'll increase the count. So if upper of I and lower of I, then I will do count plus plus. So obviously I should also declare the count variable over here. Count is equals to 0, and at the end I'm going to return my count. Let's run this and see if it works. It does. Let's submit, and it gets accepted. Okay, now let's look at the next problem. You're given a string word. A letter C is called special if it appears both in lowercase and uppercase, similar to the previous problem. And every lowercase occurrence of C appears before the first uppercase occurrence of C. So that means that there should be both lowercase and uppercase occurrences, and all lowercase occurrences of a single character should come before all the uppercase occurrences of the uh, uppercase character. So basically, all the lowercase character appearances should come before all the uppercase character appearances. So that means we have to simply, we can do whatever we are doing previously to check if it present in both uppercase and lowercase. While doing that, we can also check if it has uh, if the current character is a lowercase, we have to check if it has already encountered a uppercase character previously. If the current character is lowercase and if it has already if it if it has already encountered an uppercase character, then it is not valid. Now, if current character is a low uppercase character, then we have to see if it has encountered a lowercase character previously. So what I'm going to do is I'm going to simply uh, first paste the same code that we have written for the previous code. And on top of this, I'm going to make small changes. So if the current character is an uppercase character, um, okay, so in this case, it's it's just not enough if we just have lowercase and uppercase arrays. We'll also need another array which will actually tell us if the current character is a valid character or not. So I'm going to make it a valid character. It's not enough if if we just know that if both lowercase and uppercase are present, right? We have to know if all the lowercase characters are present before all the uppercase characters. So we have to know if the character is valid or not. So I'm going to maintain a valid array for that. So what I'm going to do is if the current uh, case is a uppercase character, if the current case is an uppercase character, then I'm going to check uh, if um, if my so if current character is a lowercase character, that means uh, previously no uppercase characters should have been marked. No uppercase character. Sorry, no. Okay, sorry. If the current character is an uppercase character, previously at least one lowercase character should have been marked. At least one lowercase character should have been marked. So that is what I'm going to check. If lower of 26, if lower of word of I minus A, if this is true, that means it has encountered a lowercase character previously. It has encountered a lowercase character previously. Now, if this is the case, what I'll do, I'll simply uh, make my valid of word of I minus as true. Okay. Now, if the character is a lowercase character, if the current character is a lowercase character, that means it shouldn't have encountered an uppercase character previously. It shouldn't have encountered an uppercase character previously. So I should check if lower of word of I minus, uh, sorry, not lower. It shouldn't encounter an uppercase character. So upper of word of I minus small a. If this should be basically false for us. If this is false, then I should mark sorry, if this is true, if it has encountered such characters previously, I'm going to mark it as false. Okay. And in this case, instead of counting if upper and lower, I'll simply count if answer of I. If this is true, then I'll simply make count plus plus. Let's see, let's run this code and check if it works. Okay, it should be valid, not answer. Okay, all three test cases passed. Let's submit and check if it works. Okay, and I got a wrong answer. Let's see what this case is. So we have, okay, so this, if you look at here, there is a lowercase, then an uppercase, then a lowercase, and then an uppercase C. So the issue comes with C over here. If you look at C, what is going on? You have a lowercase. So when this is lowercase, um, when this is lowercase, so what you will check, since upper is not marked as true yet, you will simply mark lower as true. Then you have an uppercase. When you have an uppercase, uh, you have valid of word of A is equals to true. So basically, you're going to mark it as valid when it is uppercase, because lower is marked as true. You're going to mark valid, and you will mark it as true. Then you have another lowercase. So since you have another lowercase, you are going to mark this as false. And then you have another uppercase. Then you are going to again mark it as true. But this is not valid, right? Once you encounter a lowercase character, it shouldn't be marked as true at all. It should be marked as true at all. So how do we fix this? To fix this, all I have to simply do is just just do the uppercase check. Just do the uppercase check only for the first uppercase character. Once I'm done with the first uppercase character, if I encounter any lowercase character, it is going to mark it as false, like we are doing over here. Like we are doing over here. Then if I encounter any other uppercase character, since this is not the first uppercase character, I'm not going to change my uh, value or change my valid. So all I'm going to do is, after checking if the lower of word is true or not, then I'm going to simply check if upper of word of I minus A, if this is equals to false. So if upper of word of I minus A is false, that means this is the first uppercase character that we are encountering. And if this is the first uppercase character that we are encountering, and previously if lowercase character is found, then I'm going to mark it as valid. And later, if I encounter a lowercase character, then here, as you can see, I'm going to mark it as false. Then after that, if I see another uppercase character, since that will not be the first uppercase character, I will not be changing the valid to true again. So let's see if this works now. Okay, looks like there is some, okay, there is an extra closing bracket over there. So it's that, okay, it works for the sample test cases. And what about, and it got accepted. Okay, let's look at the next question. It says here that you're given a 2D matrix grid of size m by n. Okay. In one operation, you can change the value of any cell to any non-negative number. Okay. You need to perform some operations such that each cell grid ij is equals to the cell below it. That means grid ij should be equals to grid ij plus 1 comma j. That means basically all the elements in a column should be equal. All the elements in a column should be equal, and every cell should be different from the cell to its right. That means one column value, the entire column should be having the same value. The next column should have a different value. The next column should have a different value. Return the minimum number of operations needed to change these numbers. Okay. So let's change the window here and try to understand uh, how to solve this problem. So basically, you're having a matrix. You're having a matrix of size, let's say n by m. You have to find the minimum number of operations such that each column should have equal values, and each row should have like each column value should be different than the previous value. So how do we do this? Okay, so if I want the minimum number of values, minimum number of operations, let's go back to the problem. And what are the conditions that you have here? The conditions that you have here as grid ij should be equals to grid ij plus 1, and grid ij should not be equals to grid of I comma j plus 1. So let's write those two conditions over here. So grid of ij should be equals to grid of I plus 1 j, and grid of ij should not be equals to grid of I comma j plus 1. Okay, so let's ignore the second condition for now. If I ignore the second condition for now, how will I get the answer for the first? If only first condition was present, if there is no uh, change between, like, if there is no second condition and if there is only the first condition given, what I can do, I can simply count the max count the number which is maximum repeated in a column. Let's say the count for the maximum repeated number is, let's say, 3, and uh, there are 5 elements in the column, or 5 rows, then the number of operations that I need to do for that particular column will be 2, 5 minus 3, because 3 elements will remain the same, and the other 2 elements I'm going to make this operation and change them to the same number over here. That is how I'll get the minimum number of operations. If that is if the second condition was not present, I would be simply doing this for every column and getting the minimum number of moves. But since the second condition is also there, we have to change our uh, solution. So what I'm going to do here is, I'm going to, for every column, I am going to store the count of every number. So the numbers can go anywhere from 0 to 9. So I'm going to store the count of 0, store the count of 1, store the count of 2, 3, 4, 5 for every column. Okay. So once I got it for 0th column, then I'll get for first column, second column, third column, fourth column. Let's say I have all these counts. Then let's say I'm at some ith column. Now, let's say at ith column, since because of the first condition, all the values in ith column should be the same. So because of this, let's say I want all the ith columns value to be some number uh, num. Okay, I want all the values in the ith column to be num. What are the minimum number of operations to do this? What are the minimum number of operations to get uh, make the ith columns value all the values as num? So to do that, if I'm doing this for ith column, for I minus 1 column, I can fill it with for I minus 1 column, I can fill it with 0, 1, 2, 3, all the numbers except num. The previous row can be filled with all the values except num. So similarly for I minus 2, all these can be filled with all the numbers except 0 here, uh, except 1 here, and all the numbers here again, except 2, all the numbers I have to consider, and so on. So as you can see, these are overlapping subproblems. These are overlapping subproblems. And to get the minimum value at I, it's enough if I just have the minimum value of I minus 1, 0, I minus 1, I minus 1, 1, I minus 1, 2. I'll get all the minimum values at everything except number, and out of all of these, whichever is the minimum, I'm going to consider that to calculate the value of I. So that is optimal substructure. Now, what will be the DP state over here? The DP state over here will be minimum. Okay, DP state, you'll have DP of I comma j. Uh, so DP of I comma j will give you minimum number of operations um, to or till ith column, comma, ith column being filled by j, ith column being filled by number j. So how do I calculate this? DP of I comma j will be equals to minimum of DP of I comma j will be minimum of uh, k goes from 0 to 9, and k should not be equals to j. Uh, k should not be equals to j, and minimum of DP of the previous column I minus 1 comma j, previous column I minus 1 comma sorry, I minus 1 comma k, all the values, all the possible values except j, I'm going to consider all of them, plus since I'm going to uh, get the count or number of moves with j as the number, uh, j as the current number, I can get the number of operations of the current column from this. So let's say count, uh, let's call this matrix that we are storing here as count. So count of um rows will be the number. So j comma count of j comma uh, count of j comma I will give you the current count of that column. So from that, I should subtract the number of rows. From that, I should subtract the number of rows over here. So n minus count of j comma I, count of j comma I. That will be your DP statement. Base case base case will be very simple for all I goes from 0 to n minus 1, sorry, I to 9, this because your DP table will have all elements from 0 to 9. uh, the first column DP of um, I comma 0 will be equals to n minus count of I comma 0. So this will give me the minimum number of moves that are required for each case. And table size will be what? There should be 10 rows and m columns. M is the number of columns in the original matrix. So all this should be enough for us to get to the answer. All this should be enough for us to get to the answer. So let's try to write the code for this. Okay, so first thing that I should be doing is to declare the count array and the DP array. So I'm going to declare them as vector of int. Let's call count. Uh, so first I have to give the number of rows, which will be 10, and vector of type int. There should be m columns. Any by default, or all their values will be zeros. Um, then since count is a keyword, I'll just, or count can be taken, I'll take this as DP. Okay. Uh, cool. Now first I have to populate the count matrix. So for int I should go column by column. I should go column by column, right? So for int j is equals to 0, um, j less than column, so m j plus plus. For int I is equals to 0, I less than n, I plus plus. So I'm going column by column. For each column, I'll simply populate the count. So I'll simply do count of grid of I comma j plus plus. So again, count of grid of I comma j. Uh, this will be the value at value again for jth column. Value for jth column. So count of grid of I comma j plus plus. That will populate all the counts for us. Right? Once this is done, I should use the base condition to populate the zeroth column of the DP matrix. So for int I is equals to 0, I less than 10, I plus plus, DP of I comma 0 will be equals to n minus uh, count of I comma 0. This is what we wrote previously. Now populating the actual DPI. For int I is equals to 0, I less than, sorry, I should go from column by column, right? So since I'm going column by column, I'll start with j is equals to 1 because 0th column is already done. I'm going to start with the first column. J less than m, j plus plus. For int I uh, is equals to 0 and dp matrix has only 10 rows. So I goes from 0 to I less than 10, I plus plus. What should I do now? So I should get the minimum first. I should get the minimum first. So I'm going to run another loop for int k is equals to 0, k less than 10, k plus plus. For sorry, if I is not equals to k, if I is not equals to k, I is the row. Row should not be equals to k. So if I is not equals to k, what should I do? I should simply uh, make dp of okay, let's do something like this. Initially, I'm going to take int m as int max, and then I will update min over here. M is equals to minimum of m comma dp of uh, dp of dp of sorry, k comma j, k comma j. J is the column and k will be the current row. Then I'll simply do after this for loop is done, dp of j sorry, dp of I comma j will be equals to m, and at the end my minimum value will be minimum of the last column. So I'll declare an answer variable which will be initially int max because I need the minimum value. For int I is equals to 0, I less than 10, I plus plus. I'll simply update my answer as minimum of answer comma dp of um, dp of I comma m because m will be the last column, and at the end I'll return my answer. That should be it. Let's run and see if it works. Okay, what is the issue? Okay. Right. I haven't declared m over here, so I'll just declare m as m should be the number of columns. So grid dot size will give me the number of rows to get the columns. So int m should be equals to I should also need n. So int n will be equals to grid dot size, and int m will be equals to grid grid of 0, which will be the first row, dot size, that will give me the number of columns. Now let's run and see. Okay, since m is already declared over here, I'll just make this as minimum. Okay, it is going out of bounds. Why is that? Okay, this should be minimum. Okay, the mistake here is that we should take the minimum from the previous column, not the current column. The current column's values are not populated, and we have to take the values from the previous column. And there is also one more small mistake that we did. We did not add the value of the current row to this. So to this, I have to add plus n minus count of uh, count of I comma the value that I'm taking j. I is the value that I'm taking, j is the column that I'm considering. So now let's see if this works. And this should be m minus 1. There is no nth index. So if I run this now, it works. And if I submit, it works. Submit. Yep. So yeah, that's it for this video. If you like this video, please like, share, and subscribe to our channel for more such content.